Here we have a SAT math problem. Okay, let's go to the question. In the xy plane above, the slope of line L is 2 and the slope of line M is 1. Lines L and M intersect at point P. What is the area of triangle PQR? Okay, to get the area of this triangle PQR, we need the base and height, because here we have the formula to get area of the triangle, that is base times height divided by 2. Okay, to get the height of the triangle, we have to draw a vertical line segment from the point P to the x-axis. So this vertical line segment represents the height of this triangle. Okay, now to get the height of the triangle, to get the length of this vertical line segment, we have to consider the y coordinate at the point P, that is 6. Then we have the value 6 on the y-axis over here, corresponding to this point P. So the length of this line segment over here is 6, the same length we have for this one as well. Okay, here I got the height of the triangle, that is 6. Still we need the base of the triangle. Here the line segment QR represents the base of the triangle. Now to get the length of this line segment QR, we need the point Q and R, particularly the values we have on the x-axis over here, the point Q and R. Actually these 2 points are the x-intercepts of the lines L and M. Okay, now to get the x-intercepts of the lines L and M, what we need to do is we need to get the equations of these 2 lines L and M. Okay, let's find the equation of line L. Let me write the stuff over here. Here I'm going to find the equation of line L in slope-intercept form, that is y equals to mx plus b. Okay, here m is the slope of line L. We have the slope of line L in the given information, that is 2. We can plug in 2 for this slope m, then we get y equals to 2x positive b. So this b is the y-intercept, and to get the value of this y-intercept b, what we have to do is we have to plug in one of the points on the line L into this equation. Okay, here this p of 2, 6 is a point of intersection of the 2 lines L and M. Since it's a point of intersection, we have this point 2, 6 on both the lines L and M. Okay, since we have this point 2, 6 on the line L, we can plug in this point 2, 6 into this equation. That is, we have to plug in this x coordinate 2 for x over here and the y coordinate 6 for y over here. Then I'm getting 6 equals to 2 times 2 positive b. Okay, here 6 equals to 4 positive b. Let me subtract 4 from both sides of this equation. This positive 4, negative 4 will cancel out. Here 6, negative 4 is 2. On the right side we have b. Okay, here I got the value of b. Let me plug in this 2 for b over here. Then the equation becomes y equals to 2x positive 2. Okay, now let's consider the x-intercept of the line L, that is r. To get the x-intercept of this line L, what I have to do is I have to plug in y equals to 0. Because at any point on the x-axis, the y coordinate will be 0. Okay, now let me plug in y equals to 0 here. Then 0 equals to 2x positive 2. Okay, let me subtract 2 from both sides of this equation. Then positive to negative will cancel out. I am getting negative 2 equals to 2x. Okay, let me divide both sides of this equation by 2. Then this 2 will cancel out. And here negative 2 divided by 2 is a negative 1 equals to x. Okay, here I got the x-intercept of the line L, that is negative 1. Let me mark this negative 1 over here. Okay, now we have to do the same thing to get the x-intercept of line M. Okay, now let's get the equation of line M. Let me write the stuff over here. That is line M. We can use the same slope-intercept form, that is y equals to mx plus b. Okay, here this m represents the slope of line M. So here we have the slope of line M, that is 1. We can plug in 1 for this m over here. When I plug in 1 for m over here, 1 times x is just x positive b. Now to get the value of this constant b, we have to plug in one of the points on the line M into this equation. Already we know that this 2, 6, a point of intersection we have on both the lines. So we can plug in this point into this equation. So let's plug in the x coordinate 2 for x and y coordinate 6 for y. Then we get 6 equals to 2 positive b. Let me subtract 2 from both sides. Then this 2 negative 2 will cancel out. I'm getting 4 on the left side. On the right side, I'm getting b. Okay, here I got the value of b. Okay, now let me plug in this 4 for b over here. Then we get the equation of line M, that is y equals to x positive 4. Now to get the x-intercept of line M, we have to plug in y equals to 0. Then I'm getting 0 equals to x positive 4. Let me subtract 4 from both sides. Then this positive 4, negative 4 will cancel out. On the left side, I'm getting negative 4. On the right side, we have x. Okay, here I got the x-intercept of the line M, that is negative 4. Let me mark it over here. Here we have negative 4. Already we know that this line segment QR represents the base of the triangle PQR. Now to get the length of this line segment QR, that is the base of the triangle, we have to get the distance from this value negative 1 to negative 4, that is 3 units. Therefore, the base of the triangle is 3 units. Already we have the height of the triangle, that is 6. Okay, now we can get the area of this triangle PQR. Let me write the stuff over here. That is area of triangle PQR equals to So the formula is base times height divided by 2. Here the base of the triangle is 3. We can plug in 3 for base, and the height of the triangle is 6. We can plug in 6 for height divided by 2. Okay, here 2 goes into 2 1 times, 2 goes into 6 3 times. Okay, here 3 times is 9. So the area of triangle PQR is 9 square units.